So what do minerals matter and why do we care about minerals? Well, we care about it because we need to do some rock classification, and rocks are made of minerals. So when we talk about rock classification, what is a rock? A rock is a coherent, naturally occurring solid consisting of an aggregate or a group of minerals, or less commonly of glass. So what do all these terms mean? Coherent is that a rock is held together and thus must be broken to be separated into smaller pieces. So one rock can form cliffs, or it can even be broken apart and carved into sculptures. Naturally occurring. So non-naturally occurring or man-made or manufactured materials like concrete and brick are not rocks. So when we talk about what is naturally occurring, those are rocks that are formed from minerals or through geologic processes. And an aggregate of minerals or a mass of glass, that's where a vast majority of rocks consist of a collection or a group of many mineral grains and crystals, and a few rock types consist of glass. So when we make the definition of a rock being coherent, naturally occurring, and an aggregate, that's what that means. So what holds rocks together? So a rock has grains, and the grains can stick together to form a coherent mass, either because they're bonded by natural cementing, which is mineral material that precipitates from water and fills the space between grains. So in the picture over here on the right, if we take a closer look, we have these individual grains, which could be minerals themselves. They could be small pieces of a different type of rock, and they're held together. They become bonded with each other through natural cement. This could be like some clay material or some other kind of mineral that fills the void space between these grains. And rocks whose grains are stuck together by cement are called clastics, where the grains in between are interlocked with crystals is called a crystalline rock. So these are two classifications of rocks that we're able to distinguish. One is clastic and one is crystalline. So in the clastic is where you have grains that are locked together with cement, and crystalline rock is where the grains are locked together with crystals. And we see these types of rocks in different types of rocks. So we have three different types of rocks. So when we talk about what those three different types are, we have igneous rocks, which are formed by the freezing of molten rock. Sedimentary rocks, which are formed either by cementing together fragments of existing rocks or by the precipitation of mineral crystals out of water solutions at or near the Earth's surface. And we have metamorphic rocks, which are formed when pre-existing rocks change character through heat, pressure, temperature, or chemical environment. And these are the three different types of rocks that we're going to be talking about. And each lecture, we're going to focus on these different rock classifications. So over here on the right, the top picture is an example of an igneous rock, which is formed from the cooling of molten lava. Below that, we have a sedimentary rock, and these are sands formed from grains that have eroded off this cliff. And then this metamorphic rock is a zoomed-in view of how the rock has undergone temperature and pressure, and so that's where we get this distinct feature of layering within this metamorphic rock here. So some of the ways that we can distinguish rocks from each other is through grain size and shape. And this is the dimensions of individual grains can vary greatly. Some grains you can see with your naked eye and just look at a sample, and you can see individual grains that could be the size of a pea, for example, or they can be extremely fine where you have to put them under a microscope to see them. And conversely, you can see grains that are huge, and they can be as large as a car. For composition, rocks are made of a mass of chemicals, and the proportion of chemicals affects the composition of the rock. So when we have silica rocks, for example, there's other chemicals that can be, there's different chemicals that can be part of the rock composition, and that would change the rock characteristic. It would change the color of the rock. It could change the grain size, all of these things. Okay, so the texture refers to the arrangement of the grains. So if the texture is all consistent, all the grains are all the same size, that would be a way that we'd be able to distinguish rocks from another based on their texture. And last is layering. And some rocks can contain bands of different compositions. And so this is a way that we can tell different rocks from each other based on these slight variations in the rock, if they have this layering or this foliation. So here in the picture on the right, we have a cartoon here of a rock, and without necessarily knowing what it is, what you can observe is that it does have this layering or foliation. It has different colors. And if you were to take a closer in view of that rock, you might be able to tell that there's varying grain size. And in the picture below, you can see here that there are other layering elements within this rock, and how the rock above this unit looks a little bit different than the rocks in this bottom unit. And some of the ways that we can classify rocks include looking at those outcrops. So this previous picture, this is an example of an outcrop where you see these people standing here for scale. And this is something that you'd be able to go outside and look at and see at a scale in which you could stand and view samples. And this is usually naturally available. So sometimes you have like a road cut or something, which is where part of the road has been demolished to put in a bridge or to put in a road, and therefore the side of the mountain or hill or whatever has been cut away, and it provides a face for you to look at these rocks. Usually when we say outcrop, this is the current state of the rock formation. We can also look at thin sections, which are small pieces of rock that have been collected either at an outcrop or maybe from drilling a well or something. And you would take a small slice of the rock and you would be able to do analysis on that piece of rock. So thin sections are typically about, 3 inches in diameter or so. And then all these analyses can be done on that piece of rock. It can tell you things like its porosity and permeability. It can tell you about grain size. It can tell you about it can tell you about what types of rocks are in it, if they are dissolvable, if they have been under pressure, if they can hold fluids, what type of fluids. All sorts of things can be done in a lab analysis setting. And these are all things that we will be discussing later throughout the course. But this is a brief introduction on the 3 different types of rocks and how we classify rocks.